Hi, I'm Shannon Helquist, and this is my presentation on Glacier National Park. Glacier National Park borders Montana and Canada in the northern Rocky Mountains. Early glacier and lava flows formed its geologic features through erosion, deposition, faulting, folding, and recent glaciation. Glacier has a stunning landscape, and the two things that it's probably the most famous for is its beautiful different layers of rock, as you can see here, that are layers upon layer of sandstone, shale, carbonates from the late Precambrian area, and fossils that we'll talk about here in just a minute. So in this diagram here, it's going to show us those different layers of rock. And some of those are what they call a sill, a magmatic sill. So there's the Purcell sill, the diorite sill, and probably some other sills as well. And what a sill is it's an imposing layer of rock, unlike lava, that never reached the surface in a molten state. So it intruded between beds of sedimentary rock and became a sill instead of a flow. And this picture here shows us that prominent dark gray line is the Purcell sill. And in this picture of Garden Face, you can just see more of those beautiful layers of rock. This is Mount Sia on Sunlit Peak, and it shows that this dark band here is that's that Purcell sill. So Glacier National Park has many lakes, rivers, waterfalls throughout that attracts a lot of sightseers that are formed by those ancient glaciers. So here's one of the many glaciers shown here. That a lot of these have this beautiful prominent U shape going on. This is the Boulder Glacier. And in this picture you can see that the difference between 1913 and 2007 of the Agassiz Glacier and how much it has receded and disappeared due to global warming that we've been learning about in class. And here's just another beautiful feature of the park, of those alpine mountains and forests. This is the Grinnell Glacier from Garden Wall. And here's another beautiful U-shaped valley carved out by the glaciers. This was one of my favorite parts of learning about the park. This is an ancient fossil called stromatolites that are 1.3 to 1.5 billion years old. And they are mound-like colonies of algae. So these used to cover a large part of the earth at one time, and they played a major role in increasing oxygen during the Great Oxygenation Event. So this cyanobacteria, blue-green algae, what it does is it takes carbon dioxide out of the water and it produces massive amounts of oxygen. So it played a huge role in a major event that occurred in our Earth's history. And these fossils can be found in a specific part of the park, and I think they're some of the oldest ones that can be found. Today there are still stromatolites somewhere in Australia that are actually alive today. I love this picture because it showed the scale to size with that man's hand there. So this is just one of the really cool features of the park. Thanks for coming to my presentation. I hope you enjoyed it.